Hello, everybody. Welcome. This is the SIG Architecture discussion. I seem to be one speaker short, but we'll make the best of it. So my name's John Belamaric, and I'm one of the co-chairs of SIG Architecture. And I'll talk to you a little bit today about kind of what SIG Architecture is, what role it plays in the Kubernetes community and the Kubernetes project, and the different types of issues we address and kind of things we concern ourselves with. And then, of course, I will give you a pitch for coming and getting involved and helping us out, because this is an open source community, and we really need the help and can use everybody's contribution. So generally, here he is.
Hi, everyone. Sorry, apologies, I'm late. So my nickname is Dims. I've been part of the Kubernetes community for quite some time now, and I work for AWS, and what else? I am a partner in crime in various things with John, and including the SIG Architecture. Yeah, can you do a couple of slides and then I'll catch my breath?
Yeah, absolutely. All right, thanks, Dims. Yeah, yes. So Dims and I have been working here in SIG Architecture together for probably like 6 or 7 years. So essentially, the Kubernetes project as a whole has a certain set of goals and principles, and it's kind of one of the roles of SIG Architecture to help facilitate those roles. I mean, there's other other SIGs and things that also do this, but we sort of focus on the technical architectural goals of the project. So portability, general purpose, although these days we're also extremely focused on helping Kubernetes be more effective for AI/ML workloads. But essentially, that comes kind of in the flexibility and extensibility aspects of Kubernetes. So these are kind of some of the goals. There's also a set of community values that we adhere to, and that goes into not only like how we treat each other, which is obviously very important, but it's also about how we structure the project. And it's a little funny to talk about that in the architecture, because we're talking there about kind of the organizational structure of the project, but for those of you who maybe have been around software engineering for a long time, there's a close relationship between the architecture of your organization and the architecture of the software you produce. So it is actually super important, and we run into these problems, right? We run into problems where a SIG, because it's what they understand and know, will solve a problem there, when really it probably should have been solved across 3 or 4 different SIGs, right? So part of SIG Architecture's role is a place where those SIGs can come together, and we can try and help ensure that.
Sometimes we tell them, go experiment in this one SIG and then tell us what you learned, and then we'll apply it across as well.
Right. Yes, that as well. Lessons learned, and try and move them from one lessons learned from one SIG. But to give an overview of the project, we kind of structure the project is. You want to do this one? Yeah. All right.
I caught my breath. So just before we go into this one, if you view it from the top, we have the CNCF. CNCF, well, before that, there is LF, and then CNCF is one of the foundations in LF, and then within CNCF, there is so many different projects. Kubernetes was the first one, but certainly you saw in the keynote how many projects we have. And within Kubernetes, essentially, how does Kubernetes report to the rest of the organization, right? Like, that's the way to think about it. So Kubernetes works with the other CNCF, tags and working groups, and with the TOC on different things. But then Kubernetes itself, we have a steering committee. The steering committee is not in charge of any of the technical architecture decision. They are about the health of the project. They are about sustainability of the project. They worry about the long-term consequences of doing certain things or not doing some certain things. They serve as, they go sit on the CNCF GB governing board and advocate for our project. They go figure out hey, how much cloud credits do we need, and who do we have to hound to get? So they do evangelization, they do community curation, and like, okay, is somebody being a pest in the community, on technical matters. We also have a COCC kind of body as well, but that is what steering committee does. And anything that is architecture related ends up in the SIG architecture, right? And the SIG architecture ends up asking everybody to, hey, you want to start a new group? Write a charter for yourself. Make sure that the charter doesn't overlap with the other charters that are already there, right? And that is what we call SIGs, special interest groups. So as you normally expect, there is a compute, there is a networking, there is a storage, there is a UI, there is scalability. Like those are all natural attributes of the things that you use, or natural outcomes of how we are organized ourselves. So one funny thing that you would notice is HCD is mentioned here as a SIG. How many of you know HCD as a separate project before? Right? So why is it here, right? So that was an outcome because HCD was not healthy over a long period of time. It lacked enough contributors, and we were like, okay, let's absorb a lot of the governance and security and those kinds of things that you don't really need to staff by yourself, right? The few of you who are taking care of HCD, please spend time on the code. Please spend time on the CI/CD stuff. Make sure it is healthy and make sure it is usable by Kubernetes. And it is still standalone. It can still do all the things that it used to do before, but do it under our umbrella. So we provide you the cover of the rest of the things that you need to do. Follow our processes for enhancements and things like that, right? So that is one example of something where we provide an umbrella. We kind of like, so this is what SIG architecture does, right? So we, whenever there is a problem, another example is like, hey, when we all decided to do batch-related stuff, okay, start a batch working group, right? And then give them some room to like, what does the API look like? What do the controllers need to do, right? And what are the new resources types that will be useful for everybody, right? So the working group will start working on those things and then propose some changes, and then so essentially that's over these 10 years of Kubernetes, we've evolved to this point where we have these SIGs. That doesn't mean that we prune them. We also prune things that are out of date and that are way long in the tooth, and we wrap them up and say, okay, we are moving these responsibilities to either other SIGs, or we are winding the work down, we are cleaning up the code. So we do those kind of curation tasks as well.
We also have, we also, as a project, we have working groups which are actually intentionally temporary. So if you go back to that slide, you'll see some working groups on there, and because we know that sometimes organizations just become about keeping themselves alive, so we have these working groups, and they have exit criteria, and they tend to be groups of SIGs working together, and then the code, whatever they produce, ends up back in a SIG. So this working group's a temporary working group.
Right. So as a group under Kubernetes, we also have to write a charter to tell the steering committee what we want to do, right? So, it's checks and balances, responsibilities. Just like we are asking other SIGs to write charters, we have to write one too. And this is what we ended up writing in ours as our scope. So how many of you know about the conformance program, Kubernetes conformance, right? Like it basically assures people that you go from one vendor to another vendor, distro to another distro, you end up getting exactly the same thing, right? So you develop a workload on one place, then the conformance program is the one that essentially like guarantees that these are the APIs that are available. These are the things that you can expect from Kubernetes, whether it is running on-prem or in one of the major clouds and things like that. So we also like take care of like, imagine everybody coming up with their own API conventions. Like it'll look so disjoint because people are working on these things over a long period of time, and like they might do different things at different time, and like somebody might follow certain patterns, and other people might not know those patterns, or like, they don't agree with those patterns, and then they write their own pattern. Like imagine how the APIs would look like. So SIG architecture says, here is our API conventions. It doesn't mean that it is set in stone. It just means that it's a living document. We curate it, we take care of it over a period of time. As we evolve, as our code evolves, as our community evolves, we keep it up to date. Similarly, for deprecation policy and John's favorite, production readiness, he'll talk a little bit about it at the end. And one of my favorites, which is the enhancement proposal. At one point in time, everybody was pushing code, right? Opening up PRs, asking other people in the community to review and approve, and like boom, code landed. But then what was happening was, okay, how are we going to take care of the code? How are we going to like make sure that there is some amount of like, if something goes wrong, is there a way to switch it off? Is there, things like that. You have to think through what is its effect on some of the existing features. How does it interfere with existing workloads that are expecting some things, right? So that's why we are like telling people, please write it down. Please write down what you're going to do, how you want to do it, what milestones, and like, so we are essentially trying to do this, and the KEP is a living document too, right? So you might say, hey, this latest milestone, I'm going to do these 4 things, and then next milestone, I'm going to do these next 3 things, but you couldn't do it because we are a calendar-based schedule, right? Like if your things are ready, it goes in. If it's not ready, it needs to wait for the next one. So we go back and fix the KEP and say, okay, this is what we are going to do in the next milestone. And also, like if you learn something in alpha stage, you go and fix the KEP and say, okay, we are changing what we're going to do. Maybe we'll do an alpha 2, and so on. So it's a living document, and everybody essentially gathers around it. People who want to know what is happening, go look at it. What are the PRs linked to it, right? And that's how we end up doing enhancements. So we talked a little bit about all these things, and I wanted to put up the links for each one of them. So conformance is important. API reviews are important. We literally have a set of people who are in charge of like, okay, does this API contract look good? Can we promote it from V1 Alpha 1 to V1 Beta 1? Or like, do we have to do a V1 Alpha 2 because we found something, and things are not working, and like, is there an upgrade process for this? Is there a downgrade situation where people will want to go back because something was not working? So API reviews, that's where it happens, right? Like if you, adding a field is easy, dropping a field is not easy, right? Like, and changing the meaning of a field is different as well, right? So we talk through those things in the API review process, and we already talked about some of these rest of the things. How many of you had to deal with a deprecated feature gate, or or a thing that got switched off that you were relying on in some of these workloads? Okay, at least 1, 2, 3, 4, 5, 6, 7. So we do deprecation. Like, how many of you had to switch over from Docker to Containerd? See, that's an example, right? There's more hands. Now you know what we ended up doing. So we went through a process and said, we have to tell everybody that we are doing this. We have to tell everybody that we need to clean this up, and our code base is unmaintainable because we have to support something in tree for Docker, which we are not doing for any of the other runtimes. So Docker seems to be special. We need to make it the same as containerd and cryo. So, Docker needs to move out of tree, and, we won't be supporting Docker the way we used to support Docker in the beginning, right? So we went through this process, and this is the same process that we follow for every other thing as well. So there is a, slowly over a period of time, we try to take people off existing features, especially because, we are not going from V1 of Kubernetes to V2 of Kubernetes. You might notice that, we are still in 1.33 is the next one, right? And the 1.34 is the next one. We haven't talked about 2.0. Like, we always refer to it as jokingly, right? Like, if we ever get to 2.0, but until then, these are the toggles we have, right? How do we deprecate? How do we design? So how do we move it up or down and things like that? So we also are like, the last resort here of, if there are disagreements between different teams, different SIGs who are working on different things, or like they don't know what to do, or like they need somebody else to look at the things that they are working on, they come to us. We have a meeting every 2 weeks, and they put something on the agenda, and then come talk to us. We have various mechanisms for talking to each other, but that is one of the ones that we tend to use. We do a lot of async as well. We have mailing lists, we have Slack channels, and things like that. So usually, by the time it comes to a meeting, we've already talked about it in many different forums over a period of time between many different stakeholders across different SIGs and working groups. So. That's basically how we conduct business. In terms of subprojects, what are subprojects, right? So subprojects is basically, SIG architecture is a big community, but we need people to focus on different aspects of the work that is being done in SIG architecture. So we kind of divide them up into subprojects. So we talked about conformance a few minutes ago. Conformance is one. So the people in this essentially look at okay, the current set of conformance tests, is it good? Are we missing any tests? When new tests get added, has it been flakeless in the last 2 weeks or 2 months or whatever, right? And then we end up having some criteria around that, and if you need new conformance tests, then we tell the SIGs, and hey, you're thinking about this new thing, there's a new feature or a new API, and we need to add a conformance test because we want everybody to get the same experience regardless of where they are doing it, right? Code organization. Who here have Golang projects with vast vendor dependencies? Lot of vendor code from all over the place. Quite a few, right? So this is something that you don't see, but it is there, right? Like when you use Kubernetes, you're essentially seeing things that we reuse from across the Golang ecosystem. So the code organization ensures that we are using as little as possible. Just because there is security bugs in there, and there's duplication in there. Sometimes adding a new dependency increases the size of the binary, more memory, more CPU. Maybe one of the vendor libraries has init that starts some threads, and it is doing some unnatural stuff. So there is a set of people who go around fixing these things. And some of the things that we work on in code organization takes ages. I have some charts I'll show you in a little bit. So that's the example of the different teams. John runs the production readiness reviews. Jordan runs some of the API reviews. I help out with the code organization. So we have some specific people doing specific things, and we have some folks who help us. So that's the organization model. So API reviews, we talked a little bit about it already. We do have a project board, if you're interested. It is, you have, if you go through one of the issues and see exactly what ended up happening, then you will figure out like, oh, this is why they did it, right? Like, so the aha moments are endless. I hang out with the API review folks. I don't work on it directly, but if you should look at the API conventions. You should look at the API changes, markdown file too, because if you are writing code, if you're writing controllers, if you're doing work in the Kubernetes community, then you should know this by heart. So it's because that's what we look for, and that's what whenever you have a PR open and things like that, we kind of like make sure that you are following all these things.
Well, and I would say even if you don't want to contribute upstream to Kubernetes, if you're building anything on top of Kubernetes, so you're building controllers for CRDs or anything like that, I would highly recommend you go and get familiar with the API conventions we use. They're all there for a reason. So this is kind of the institutional knowledge of 10 years of building Kubernetes-based APIs. And if your controllers follow the same conventions, it's likely that there will be ecosystem, like tooling and things will be able to handle your CRDs and your CRs and things better than they would be otherwise.
And essentially, don't make the mistakes we already made. Learn from what we did already. So this is an example of the conformance tests we have made. So when we started doing conformance tests, we did have a lot of gaps in there, but we've closed the gaps over a long period of time. It literally took us years to make sure that all APIs that we publish are tested and in conformance. So happy to say that I think in 131 or 132 we were able to close that gap. And now what we are doing is whenever we land new features, new KEPs, all APIs have to come, and by the time they graduate from alpha to beta to GA, they will end up having conformance tests. So we don't have to go back and catch up later. Code organization, this is my special project. I love doing this. It's maintenance grunt work. Each thing that we end up doing, it takes a very long time because it's spread across various different things. Simple example from that I can give you is like some of the PRs and some of the work that we ended up doing in code organization spreads across like the open containers runc, containerd project, and HCD project, and several other projects. So this is the convoluted graph that we have, and this is just part of the graph. So this is not even the full graph. So I talked about cleaning up dependencies. So if you look at the bottom, you will see all the versions. You can see the number of vendored file going crazy, and then the number of vendored line of code. It was going to touch 2 million lines. Imagine that, right? What an attack vector, right? Anybody who has code that ends up in Kubernetes, there's an attack vector right there. So we've been able to bring it down significantly by cleaning up, pruning, negotiating, deduplicating, and things like that. And like if you look at the dependency counts at the bottom, you can see the master, extremely happy with that result right now. But doesn't mean that it's the end of the road. There's more work to do, and always, we always look for help. So with that, I will hand it over to John a little bit more, and I'll take a break.
All right, great. So I think we have 5 minutes or so left. Is that about right? Yeah, okay. So I'll try and be quick because we'll try and leave a little bit of time for questions here. But as Dims was saying, we have these different subprojects. Each subproject has different responsibilities. Enhancements looks at how we actually add features to Kubernetes and make sure that the work that people are doing adheres to certain design principles and things like that. Production readiness review is, as we add features to Kubernetes, we want to make sure that they evolve through a process. They start in alpha, they go to beta, they go to GA, but what does that mean? What does it mean to go from alpha? What does it mean to create a new feature, we have certain requirements to make sure that we don't break your clusters, that you can turn things off, that you can downgrade and then upgrade again. So that's part of production readiness review, and that you can monitor your clusters. So one of the big things that, as a project, we're working on, and therefore SIG Architecture is involved in, while we continue to try and build reliability and trust, that includes production readiness reviews as well as upgrades. So you may have heard something about this compatibility version. So that's part of the SIG Architecture is one of the SIGs involved in that, but that's an idea for how we can decouple binary upgrades from API upgrades, which makes it safer to you can do multi-stage upgrades more easily. And then, of course, we're trying to work on how Kubernetes relates to AI/ML workloads, how it relates to hardware, how we can make it most useful in those situations. I'm going to skip all this and go to Q&A. So, any questions here?
Lots more to talk about, but we would like to take questions.
There are no questions. All right. Well, what I would like to say is, here we have one. All right.
Microphone. Oh, yeah, it's on. So, looking back at the beginnings of Kubernetes, let's say the version that was still written in Python, how much of that would make it through the current process if it were to be validated the same way?
Yeah, it wouldn't, but we are not the same project, right? We didn't have millions and millions of clusters and users depending on us then, right? And that predates me in Kubernetes. I've been eight years I've been involved, and so even that, yeah, no. So your point is, I think, well taken. That one, it means that the bar has been raised substantially for what can get in the door, and it has to be, because we have to not break, you want your banking app to keep working, and it's probably running on Kubernetes. So.
Thank you for your question.
Yeah, in essence, we've come very far.
Yes.
Yes.
Absolutely. Absolutely.
Anyone else?
All right, well, thank you, and please come join us. We'll put this deck up on the Sketch, and you'll see links for how to get involved. We always need more help here in Kubernetes. Thank you.